A police van moving on a highway with a speed of 30 kilometers per hour fires a bullet at a thief's car speeding away in the same direction with a speed of 192 kilometers per hour. So let us draw this. Let us say this is the road and here is the thief's car and it is speeding away at 192 kilometers per hour this way, and at the same time there is a police car that is traveling behind and this car is moving with a speed of 30 kilometers per hour in the same direction, and then this police car shoots a bullet at 150 meters per second. Now before we proceed, the first thing that we must do is to convert all quantities to meters per second. So let us look at what 30 kilometers per hour and 192 kilometers per hour is going to be. And let's convert 30 kilometers per hour. 30 kilometers per hour is 30 into 1000 meters per 3600 seconds. And so cancelling out the two zeros here, we get 30 into 10 by 36. And dividing by 3, we get 10 and 12 here. And this is 100 by 12. And if I divide that out by 4, 100 becomes 25, 12 becomes 3. And so 30 kilometers per hour is 25 by 3 meters per second. And now let us convert 192 kilometers per hour, and that is 192 into 1000 meters by 3600 seconds, and so the zeros get cancelled. And if I now divide this by 6, this is 6 times 6 is 36, and 6 times 32 is 192, and so we get 32 into 10 by 6. And now cancelling out the 2 here, this becomes 3, this becomes 16, and so I have 160 by 3 meters per second. So 192 kilometers per hour, 160 meters per second. And so now we have converted the police car and the thief's car's velocity into meters per second. The police car's velocity is 25 by 3 meters per second and the thief's car's velocity is 160 by 3 meters per second. And all this is obviously as seen by an observer on the ground. This is from the ground reference frame. And now let us look at the problem. The problem says that the muzzle speed of the bullet is 150 meters per second. So suppose I draw the bullet here. I can't say that its velocity here is 150 meters per second because this is the ground frames diagram and this speed is as seen by somebody in the police car, and so I should draw the second diagram, which is the police car's diagram. And in this diagram obviously the police car has a velocity 0 and here the bullet has a velocity of 150 meters per second. This is as seen by somebody in the police car. And since the police car is the common object between this diagram and that diagram, I must make its velocity the same if I want to translate this bullet's velocity from here to the ground reference frame. And to do that, I must add a velocity of 25 by 3 meters per second to all quantities. If I do that to the police car, its velocity becomes 25 by 3 because 0 plus 25 by 3. But the bullet's velocity then becomes 150 plus 25 by 3. And all of this is in meters per second. The question we have been asked is to find out the speed that is relevant for damaging the thief's car, and the speed that is relevant for damaging the thief's car is the speed with which the bullet hits according to the thief's car. That means we must make the thief's car 0 and we want to find out what is the bullet speed relative to the thief's car. And the way we are going to do that is to draw another diagram, and this is the thief's car's diagram. And in this diagram, the thief's car obviously has a velocity 0 meters per second. And the way we are going to convert this 160 by 3 meters per second to 0 is to obviously add a velocity of 160 by 3 meters per second to all quantities on the ground frame. And that means also to the bullet. And the bullet has 150 plus 25 by 3 this way. And you have to add to it 160 by 3 meters per second this way. And so I get 150 plus 25 by 3 minus 160 by 3 meters per second. And so this is the speed with which the bullet comes and hits the thief's car as seen from the thief's reference frame. And so this is obviously the speed which would be damaging the thief's car. And so if I look at this, you can see that it is 150 minus, and 25 minus 160 is minus 135 by 3, and this is in meters per second. And this is the speed of the bullet as seen by the thief's car, and 135 by 3 is 45, and so I can write this down as 150 minus 45 meters per second, which is 105 meters per second. So that means the speed that is relevant for damaging the thief's car, the speed with which the bullet hits the thief's car, is 105 meters per second.